We are graphing secant and cosecant today. In order to graph secant and cosecant, they are very much based on their reciprocals, sine and cosine. Now, if you're trying to find this in the book, this is in lesson 4.5. I call it lesson 4.5.1 because secant, cosecant, tangent, and cotangent are all in lesson 4.5. We are just focused on secant and cosecant today. Yes?
This is very off topic, but I saw that they are having a Pi Day.
Talk another time. Okay. Key piece of information here. First of all, zeros. Okay. What do I mean by when I use the vocabulary word zeros?
X-intercepts.
Okay, x-intercepts, right? So zeros, or x-intercepts on the graph of sine and cosine, become asymptotes on these secant, cosecant graphs. Remember, asymptotes being those dotted lines we draw that our graph will never cross and never touch. Okay? And then the hills and valleys. So those humps or hills and valleys will flip. So if you have a sine curve that has the mountain and valley, what's going to happen is those hills and valleys are going to flip and become parabolas that either open up or down. Okay, I'll take you through it. And those are going to be between the asymptotes. So let's look at secant here. My goal today is to get through the basics with secant and cosecant so you at least have some information about how they work. And then honestly, you're using your sine and cosine information from prior. So, okay, secant is the reciprocal of cosine. This is kind of scary. Secant, the one beginning with S, is reciprocal of cosine, the one beginning with C.
Yeah,
So, now, so in order to graph secant, we start off by graphing cosine. Nothing fancy on this one. No period changes, no phase shifts, no amplitude, no center line changes, just basic cosine. So if we're graphing cosine, what's a basic cycle of cosine look like?
2 pi.
Goes from 0 to 2 pi. With 0 to 2 pi, I'm going to go ahead and label the middle as pi. And then when I label the middle of those halves, the middle of 0 and pi is pi over 2. The middle of 1 pi and 2 pi is 3 pi over 2. Old news, right? Now, with that in mind, I need to put on my amplitude of just a regular graph is 1 and -1. And I'm going to tell you, I would not use all of your y-axis to make your 1 and -1. It's fine when you're doing a sine and cosine curve, but we need room to flip our hills and valleys. And those are going to flip up past. Okay? Trying to warn you here. Now, I'm going to go ahead and just kind of trace in my cosine curve. This is not a solid line. This is a dotted line because this cosine curve is just setting us up to graph secant. But I need to see it to make sure I get my secant in the right spot. So if you remember, a cosine curve starts up high, cuts through at pi over 2, has a minimum under pi, crosses through at 3 pi over 2, and has a maximum above 2 pi. That's the basics from yesterday, right? As I said, it's a dotted line, so it's just I'm just using it to help place my cosine, or my secant curve. Now, next step it says is to draw the asymptotes. Where are the asymptotes going to be? zeros on the graph become asymptotes. So a 0 is any place my graph crosses the x-axis. So for instance, there was a 0 at pi over 2. What am I going to have here now instead? An asymptote. There was a 0 at 3 pi over 2. What am I going to have here instead? Asymptote. Next part, draw the parabolas going outward, and you're done. So I'm going to start here in the middle because that's the easiest place. In the middle I have a valley, yes? The bottom of that valley is underneath pi at a level of -1, yes? So I'm going to flip that valley upside down so that it is now a parabola going upside down, where the top of that parabola is at the point pi -1. So it is what I would call tangent to my cosine curve, because it's touching my cosine curve. It's not that it's crossing into it or anything, but they touch. They're tangent to each other. Now, officially, if we go back here, I only started my graph at 0, didn't I? So officially, what I have right here is there's half of a hill. So when I flip that half of a hill up top, officially I have half of a parabola. Now, I might continue that and put the full parabola here in a moment.
Do we have to draw that?
Yeah, when you do a secant or cosecant curve, there's always going to be the equivalence of two parabolas. So here's a half, here's 1, and then from 3 pi to 2 pi, 3 pi over 2 to 2 pi, there's half of a hill, right? So when I flip that upside down, there's going to be half of a parabola. This right here, what's in the red, and I guess maybe I should have had my asymptotes in red, but this right here is what the secant curve looks like. Okay, the blue was my cosine curve that was just setting it up. The red is the secant curve. Now, that's the minimum requirement for a cycle. If that is bothering you to have the half parabolas, could you draw the rest of the parabolas in? You can. You could draw the rest of the parabolas in. I'm not saying you have to, because now I technically have 3 parabolas. I only need the equivalence of 2. But realize what would happen here, right? If I continued this cosine curve back here, it would cross through at, bless you, -pi over 2. If I continued my cosine curve over here on the right, it would cross through at 5 pi over 2. And so the idea is that there would be another set of asymptotes, right? Realize when you graph just secant, and you look at secant on your calculator, it's just going to be alternating parabolas. Okay? That's all it's going to be. Questions I should answer here?
Are we going to be required to show the dotted line?
I do expect you to show, in this case, the cosine curve, because that puts the parabolas in the right spots. Okay? So, huh?
It will help.
Yeah.
This looks so weird.
Okay. That was kind of your beginning run. Cosecant. The one beginning with C is the reciprocal of sine. So what do I have to graph first? Sine. Sine, just like cosine, has a period of 2 pi. The middle of 2 pi is pi. Middle of 0 and pi is pi over 2. The middle of pi and 2 pi is 3 pi over 2. I have a high and low value of 1 and negative 1. And you did see now why I didn't put that 1 and negative 1 all the way at the top and bottom, didn't I? Because I need room for these parabolas. Even this is going to be squished in. Okay, how talented are you to just draw the basic sine curve? Sine starts at 0, 0. I'm going to have a max above pi over 2. I'm going to cross through pi. A minimum under 3 pi over 2. I'm going to cross through 2 pi. Are you at least getting used to what sine and cosine look like? You're getting those stuck in your head because you're going to have to know that, obviously. After you draw sine, we're going to draw the asymptotes. Where are asymptotes?
Pi and 2, 0. Oh, wait, and 0.
Okay, so there's technically 3 required here. At 0, so at the y-axis, at pi, and at 2 pi. Because those are my zeros. Those are the places my sine curve crosses through the x-axis. What's going to happen between 0 and 1 pi? My hill's going to flip up, right? And so I'm going to have a parabola that opens upward. That's going to be between my asymptotes. The bottom of that parabola is above pi over 2 and at a height of 1. Between 1 pi and 2 pi, there's a valley. So I'm going to take that valley and flip it upside down. So I have a parabola between 1 pi and 2 pi that its max is right under 3 pi over 2 at a height of negative 1.
Do we have to keep going?
No.
Or we only have to 2?
So anytime we do secant or cosecant, my rule is always I'm looking for the minimum requirement is the equivalence of 2 parabolas. With a cosecant graph, you get exactly 2. Okay? Excuse me. With a secant graph, what we did up here, the equivalence of 2 would be 1 and 2 halves. Because remember how I started off and some of you didn't really care for the look of 1 full parabola and 2 half parabolas? So then I just went ahead and finished it out. And so 3 parabolas is fine here, but the minimum requirement, you wouldn't have to have this left half, and you wouldn't have to have that right half over there. Does that make sense? So the equivalence of 2 parabolas is what I'm always looking for there. Okay. I'm going to stop there because I don't want to get stuck in the middle of number 1, which is exactly what we do. Okay. My morning class, I only have half a class tomorrow. Not exactly sure how I'm going to work this, but my plan for you guys at least is we're going to do several of these examples. I think there's only 4 examples. I'm thinking like maybe I have 3 done in here, but I'm going to do a couple examples. The homework is not going to be due until Thursday. Okay, I'll go ahead and give you the worksheet. And honestly, use what you know yesterday about sine and cosine, because you're drawing sine and cosine, right? And then asymptotes, parabolas.
So with like Like all the other numbers that are added to the equation.
You're doing center line, amplitude, period,
You
phase
just
shift.
do that like sine and cosine and then just flip it.
Yep, pretty much, yeah. So you're doing it just like sine and cosine.
What does this do? Thursday.
Yeah, the worksheet won't be due till Thursday. I mean, I don't have half of my morning class tomorrow. And honestly, my plan is I want to go over some examples with you. Because do you guys still need some more practice on sine and all the periods and phase shift and stuff?
Yeah.
Yes. It would be beneficial for me to go over some more practice with that. So that is why I do plan to go over more examples tomorrow. Okay?